Alright, so let's look at just kind of a generic reaction. Let's say I just have A plus 2B makes C plus D. Let's just say they're all gas. So obviously you can't balance this because it's just made up things. But on the test or in the future, be sure you balance whatever I give you. So the first thing we talked about was how different factors influence equilibrium. So we know that equilibrium is when the forward and reverse rates are equal. So what's the rule that we look at to see how different factors influence equilibrium, how a change affects equilibrium? Whose rule or principle? Le Chatelier's principle. Okay, so Le Chatelier's principle simply talks about how a change on our part influences the equilibrium of a system. So there are three major things that we looked at. First is adding something or taking away something, a reactant or a product. We said that a change in pressure affects equilibrium if we have a what present? Gas. So pressure typically only affects gases, and then a change in temperature will affect the equilibrium. Then we also said that catalysts do not affect equilibrium. We know that catalysts lower activation energy, which increase the rate, but it increases both the forward and the reverse rate equally. So if it changes the forward and the reverse rate equally, they're still equal, so equilibrium is unchanged. So let's look at some examples of Le Chatelier's principle. So let's say first that I have this situation at equilibrium, and then I want to remove some C. And so I take some of the product away. So if I remove C, will that shift equilibrium to the left or to the right? To the right. So to the right or towards the product side, however you want to word it. So that's one way to simply ask it. I could also ask, if I remove C, what does it do to the concentration of A? So it shifts to the right. So does the right reaction produce A or use up A? Uses it up. So increase or decrease A? Decrease. Then what does it do to the concentration of D? It increases it because the right reaction produces D. So several ways to ask that same question. Removing C shifts which way, does what to the concentration of A, does what to the concentration of D. Okay? Then I could say, what if I add B? If I add B, do I shift to the left or to the right? To the right as well. So I add B, the reaction wants to compensate by using up that B. So to use up that B, it goes to the right. So if this also shifts to the right, does it have the same effect on A and D as did the previous one? Yeah. So it also decreases A and decreases D. So we can't comment on the extent to which it increases or decreases because that depends on how much I remove or how much I add. So we can't say by this much. It's kind of a generic comparison. So then what if I say I increase pressure? If I increase pressure, it shifts towards the side with the fewer number of what? Moles of gas. I only care about gas particles. How many gas particles are on the reactant side up here? 3. How many on the product side? 2. So which way does it shift, left or right? To the right. So would the same statements also be true here? A decreases, D increases. Okay. Then let's say increase temperature. Can I answer that question? Now I know it changes. What do I need to know how it changes? Which side energy zone, so if the reaction is endothermic or exothermic. So I can say if endo, and FXO. So if it's endothermic, is energy a reactant or a product? Reactant. So if I add reactant, do I shift to the left or the right? The right. Then if that's correct, XO has to be what? Left. Well, let's look at it. So if energy is over here and I add energy, will it shift to the left? Yes. Okay. I tend to ask that in terms of increasing, but could I also ask it in terms of decreasing temperature? Yeah, it should be the exact opposite. Okay. So if increasing shifts endo right, decreasing shifts endo left. So I could also ask any of these in reverse. Okay. Then could also ask this in terms of increasing A, increasing B, and stuff like that. Yeah. So then let's say I write PD above the arrow. Writing PD above the arrow tells me that palladium is a what? Catalyst. So then I could ask, if I add PD, what happens? Nothing. So neither. So it shifts neither left nor right. It's unchanged. Would the rate be affected? Yes. But the equilibrium is unaffected there. And that's really it for Le Chatelier's principle. I could ask a bunch of different ways, but those are really the basic questions we can answer there. Just a bunch of different ways to word that. You have to recognize what's going on. Okay. Then the next thing we did was wrote equilibrium expressions to calculate equilibrium constants. So what is the symbol for an equilibrium constant? Okay. What are the units for equilibrium constants? There are no units. Okay. So for rate constant, they were complicated. For equilibrium constant, it is unitless, dimensionless. Okay. So I calculate K by the concentration of products divided by the concentration of reactants, all raised to the power of their coefficient. So I can say K equals the concentration of A, gas, concentration of B, gas. Is that correct? No. What's wrong with that? What have I done wrong? Well, if I raise it the second, it's still wrong.
You have to put C and D on.
Yeah, it's backwards. C and D are on top. Okay. It's very logical to put reactants first. Okay. By far the most common thing I see messed up. For some reason, half people tend to do it. So don't do that. Okay. It's products over reactants. That's wrong. So K equals concentration of C, gas, concentration of D, gas, divided by concentration of A, gas, concentration of B, gas. Now is it right?
No, you have to put it next to the coefficient.
You gotta raise the coefficient. Do I have to write the ones? No, can I if I want to? Yeah, but you have to square it. Okay. So these brackets are just the concentration of these chemicals when it's at equilibrium. Okay. So if the denominator is larger than the numerator, the value of K is going to be what? Less than 1. Okay? So if K is less than 1, if the denominator is larger than the numerator, are there more products or more reactants? More reactants. So if K is less than 1, you can say reactants favored. If you forget that, just think about which one makes it bigger, numerator or denominator there. So then if K is greater than 1, products are favored. Then, could I give you some concentrations for C, D, A, and B and ask you to solve for K? Yeah. Could I just give you some numbers and ask you to tell me if the products or reactants are favored? Yeah. If it's greater than 1, products, less than 1, reactants. Okay. So the way you'll typically see it, and there's some in the study guide, is I'll just give you a reaction and ask you to solve for K, and I'll give you the concentration. So you have to first write the expression and then plug in and solve for K. Okay? So one other kind of example, you'll see something like write equilibrium expression for dissolving of whatever X might be. Okay? So first you write the reaction, so I can say X solid plus H2O liquid makes whatever it is when it dissolves. Okay? And what do ionic compounds do when they dissolve? They dissociate. So I might have A plus AQ plus B minus AQ. Then when I write the expression, what two things do I include in my equilibrium expressions? Things that are gas and aqueous. So gas and aqueous get included, so that leaves out what two things? Solids and liquids. Okay. So in this, do I include X or H2O liquid? No. So my K will just equal concentration of A plus, concentration of B minus. Okay. Typically written as KSP. We'll discuss that more in the next chapter. So whatever type of K you have, it's really the same thing, products over reactants. Then if there were a coefficient, I would raise that to the power. Okay. So the only math here is they give you the numbers and you plug in and solve. So the math's pretty straightforward. The only kind of complicated part is thinking about Le Chatelier's principle. Okay. So any questions about that? Good. Let me stop recording.